Hi guys, it's Mr. Tuberville again, and on this video we're going to be talking about solving absolute value equations, and it's in section 2 of our current textbook of module 2. And while we are going to talk about solving absolute value equations, I will show you the proper way to do that algebraically. One of the primary roles of this particular section is really to show you how to solve any equation as long as the answer is a real number. And what does that mean? Well, I'll show you more about what that means here in just a minute. But let's get through the official stuff first, and then I'll start showing you some really cool things that we can do on the calculator. All right, so let's go to our next thing here, officially here. Get this thing slid over. Every time I do it, I have to re-slide it up. Okay, so how can I solve an absolute value equation? Well, you got to realize, is there just one thing I can plug in here for x to make it equal to? Actually, in this case, there's going to be two different answers. And so how would you do that? Well, this is the official way that you would have to do it. Let's actually, I tell you what, let's do this question first. Let's do this question first. I think this might be even more helpful to explain what we're talking about, and then come back to that other one. So we're going to start with a simpler equation, because they talk about absolute value could be positive a and negative a sitting here on this page here. But here's a simpler equation to start off with. And what they've done is they subtracted 2 from both sides, and that's how they got the absolute value of 3x equals 6. Now, if you just divided by 3, you would get 2, right? Well, what did they do? Well, they dropped the absolute value bars and wrote the problem just like it's written and just without the absolute value bars. Then they wrote it again, but this time with a negative. Now let's see how that works out. Well, if you divide both sides by 3, you get a 2. If you divide both sides by 3 over here, you get negative 2. Now, does that work, though? Is that legit? So if I plug a 2 in, 2 times 3, well, that's 6, sure enough. What about negative 2, though? That's what this extra stuff came in. So let's do negative 2 and check if it's a true solution, because the solution is that which you can plug in that makes it true. So let's plug it in and see if it makes it true. So 3 times negative 2, well, that's negative 6. And when you take the absolute value of negative 6, it's positive 6, because absolute value is always the distance from 0. Okay? And so what does that look like? Well, when they plotted these on a number line, negative 2 and positive 2, because these are both the solutions to this absolute value equation. Now, briefly here, let's do a quick look at something over here in the homework. It's a little bit weird. And so something very similar to this is going to end up being, when you divide by 2, it's going to be 3 over 2, which is 1.5. And you're going to get positive 1.5 and negative 1.5 for this problem. And I skipped a lot of stuff there, and you'll figure that before that. But I just want to make sure you get what's going on. So if the answer is 1.5, you hit the negative 1.5. We hit smaller solution. And we're going to hit right there. And then we go the larger solution, and in this case it's 1.5 as well. That isn't always the case, guys. As the equations get a little bit more complex. And now let's check our answer. There we go. So instead of putting your dot on the number line, on a piece of paper, they're doing left and right side here, and that's how that would work. Okay. So that's a real simple one. But so let's go up here now and let's look at the one that's a little bit more challenging. All right, so let's work out this guy in this official procedure. Okay, so I've slid this over and I've recopied over, so we got some room to work. And I'm going to show you how this official algebra way to do this. So let's just solve it like this. The absolute values aren't bothering us any. So we're going to add 4 to both sides of our equation. Okay, and do our like terms. Let's go left to right. So nothing happened to these guys, because they're just going to come along, stay the same. Just bring them down. Negative 4 and positive 4, that does cancel. Remember to double check that. Bring down my equal sign, and 2 plus 4 is 6. All right, just in case, we're going to make this nice and clear. That looks like a not equal. That's craziness. Let's make sure that does say equal. There we go. Now you can't really distribute through the absolute values. I know some people are going to want to try, but let's just do, that's 2 times. Let's do division. Let's do division. Divide both sides by 2. All right. So x minus 5 in absolute value bars is equal to 3. 6 divided by 2 is 3. Okay. So this is what we've gotten down. We've taken this equation and we have simplified it down as far as we could go. We've got the absolute value on one side and everything else on the other side. So that's the first thing you kind of got to do. And that's just like we did on this other problem a while ago. They subtracted the 2 on both sides and got that absolute value by itself. Okay? So that's okay there. So let's get this back over here. Every time I got to move it over. Huh? That's okay. But what did we do a while ago? Once we had that situation, we wrote it twice, exactly the same. So we're going to write it. I'm going to go to blue now, though. I'm going to x minus 5 equals 3. And then I'm going to write it again. X minus 5 equals 3. But on this occasion, what are we going to do? We're going to make this the opposite sign, okay? And now I just got to warn you, not always is it just a 3. It could be something else over there, okay? But you're going to do the opposite of whatever's over there, okay? So we got the same thing exactly twice, but because the absolute value could have that positive negative thing running. And we've got, so first thing we did was simplify it to just absolute value. Now we wrote it twice. Second one's got a negative. On our next section, it's going to be kind of the same thing, except it'll have an inequality symbol, but the steps will be the same up to that point. Well, here's a pretty straightforward thing. So we add 5 to both sides, and we get x equals 8. Add 5 to both sides, x equals 2. Okay, and so here are our two answers. We could plug in an 8 or a 2. Let's do a quick check on that. So 8 minus 5, that'd be 3, right? And 2 times 3 would be 6. Let's put it over here, 6. And then if I subtract 4, I get 2. So 8's okay. 8 is a solution because I could plug it back in and make it true. So now let's try 2. Let's plug in 2. So 2 minus 5 gives me negative 3, right? Negative 3. But what is the absolute value of negative 3? Positive 3. Then 2 times 3 would be 6. And again, 6 minus 4 is 2. So 2 different answers there. Okay, now I wonder why this graph is even sitting there. This is interesting. Well, they're saying, what if we took this and broke it up into 2 separate functions? And we graph the left side and then we graph the right side. What would end up happening here? So our first thing we're going to do is let's get this guy here. And we see. So so we're going to take the right-hand side. I said red. Red. There we go. So they've taken this right-hand side and made it its own little equation. So, and that ends up being just 2. Y equals 2. So it gives me this little guy right through here. Okay. Not perfect, but it's close. Okay. It's because it's going by 2's. And then now we're ready to graph this other guy. Graph this other one. And so let me give it a nice blue circle so it goes with our blue line. So it's a V shape, but it's going to go down 4, right 5, and have a slope of 2. Okay, which makes it more interesting. So it's going to go down 4. Let me put some dots down first, so as opposed to just the arrows. So 2, 4, and right 5. So 2, 4 plus 1. So there's my vertex. Okay, there's my vertex down. Oops, that's not true at all either. I was going from the line, wasn't it? And sometimes people do that. Nope, that is not the right way to do it. You start from the vertex because that's how it started. So down 4, right 5, and now we got our vertex. Here we go. And our slope is 2, so it's going to go up 2 over 1. up 2 over 1. You got to be careful because this is going by 2's, right? But you kind of see your pattern pretty quickly. And then you just reverse your pattern. Go back to my little ray here. And that's how you graph too, guys. You plot your points, then play connect the dot in that order always. Otherwise, we call it sketching. Okay, and there's a time for sketching, but not when it's time to graph. It's not time to sketch when it's time to graph. All right, so here we go. And well, looky there. You see what just happened? Look at that right there. It's crossing at 2 and 8. At x equals 2 and x equals 8. They're crossing each other. They're intersecting. Well, that's not a coincidence. That happens every time. And so that's pretty cool. So you could go through and graph all these by hand and figure that out. And that's great. That's fine. But this is a place where our calculator is very, very helpful. Oops, let me put this in here in case somebody was wanting to know a little bit later. That goes over there. There we go. All right, so let's go look at some more examples. And like this guy here. So I can graph this guy pretty quickly here. I'm not going to do all of them, but I can graph this one pretty quick. So x equals 5. I mean, we got up 2 and right 3. So up 2, right 3. Okay. And then the slope is just 1, right? Well, here's the cool thing. When you're doing a slope of 1, that's really up 2 over 2, isn't it? But that's okay because that still equals 1, doesn't it? So when you're counting off rise and run, you can just count the squares, no matter what the scale is, you can still just count up the squares like you would if it was 1. Because it's a ratio, it would reduce down back to the same thing. So that's the nice thing there about that. Up and over, up and over. Let's go. That guy. And so this isn't a whole lot of trouble, is it? I put this on a straight line, and our other one, the 5, goes right through here, doesn't it? And so I can see that x equals 0 and x equals 6 is going to be our answers, okay? So our answers are going to be x equals 0 and x equals 6. I already know that to be our answers, but let me show you the cool thing how we can use our calculator. And this is really one of the main things I want you to do in this section. I wanted to show you how this other stuff works, but the main thing I wanted you to really practice a lot, because we're doing 1 through 15, because I want you to practice this skill a lot, using our calculator to find these intersecting points. So I'm going to graph this right off the bat and see here. Whoop, clear that guy out of there. Uh-oh, I've done forgot what it said. What did it say? Okay, absolute value of x minus 3 plus 2. So I'd like to do alpha window, which is F2. Pick 1. There's my absolute value of x minus 3. So x minus 3. Okay, now I'm going to get out of the absolute values. And I think it said plus 2. Let me check real quickly here. Yes, plus 2, and the other was 5, right? And so I'm going to come down, hit the down arrow and put a 5 in. Well, that's really down, wasn't it? Didn't mean to go down that far. Let's just delete that. Let's come back up. Didn't mean to go that far. Wow, this thing's getting touches. There we go. 5. Goodness gracious. Now I'm going to hit zoom 6. That gets us to our standard window. Boom. That's real quick. It's a lot faster than on my calculator, right? And now watch this. I'm going to hit, remember on the top row of your calculator, that's where all the graphing things is. So I want to calculate where they intersect. So I'm going to hit second calc, number 5. Now I'm just hitting the 5. You can go down and hit enter. And here's the deal. It says first curve. I'm just going to hit enter. And then second curve, enter. And then enter. And there it is. Now that was weird. It didn't move anywhere. So there it is. Our first answer is x equals 0. But what about y? Remember, our first original equation didn't have a y. We created the two equations and made a y, didn't we? And so we know that both of them are going to have the same y value. Okay, they're both going to have the same y value. It's because that's where they intersect. We're worried about the x value. Now, what about the other one though? Do I do the same thing? I'm just going to hit second calc. Whoops, that's no. Try again. Quit. Okay. Second calc intersect enter enter enter. Well, it didn't give me the other one. It worked the last time. Why didn't it work this time? Well, what it does is it calculates the nearest intersection, whatever is the closest one. And so if you wanted to do one that's not real close, you got to move your little X, I call it my little spider, crawling across those webs there. And so this time I'm going to hit second calc intersect. But before I start hitting enter, I'm going to move, and if you notice, I'm hitting the right arrow, not the up and down arrow. Because if I hit the up and down arrow, see what happens. It goes from one equation to the other. So if I want to go across one of these lines, I got to hit the right and left arrow. So now I've moved closer to the other one, and I don't have to even be that close, okay? I can be anywhere in the neighborhood. As long as that X is closer to that intersection than the other one, now I can just pretty much go enter, 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 and bam, there's my 6. And we said the X is going to be X equals 0 and X equals 6, okay? And so that's how you can use your calculator to solve almost anything. But just briefly, let me go over here and say, what would happen if that was a -5? Now what's going to happen when I hit zoom 6? Well, they don't cross at all, do they? Okay, so that's one of the downsides of being able to try to solve an equation by graphing. It's great. It's really great. And sometimes you have to do a lot of zooming in and out to be able to see your picture. But what it can't do is solve equations that don't have a real answer, which means they don't cross each other. So that these two can cross none, like this one, or I could actually move that up. What if I made that y equals, let's come on down and clear and make that a 2. What's going to look at that graph now? How many times it touched now? 1. So in that scenario, it has one solution, okay, which would be 1 to 3, x equals 3. And so you can have 2 solutions, 1 solution, or no real solutions. And when we get to parabolas, we're going to find another way to deal with those issues. And we're going to go talk about imaginary numbers. What? Using our imagination? Well, not quite. But right now, we're just talking about how to solve almost any equation using graphing. Okay? So let's jump on down here and try us another equation here. So let me write this one down real quick so I have to go back and forth. All right, so we got our y equals. I cleared it out. So let's put this guy in here. 2, and it's to get to the F2 where the absolute value is. I hit alpha, window. Okay, again, another way people like to do that is that the catalog, which is second 0. And now I'm going to put in x plus 1. I'm going to pop out that absolute value by hitting the right arrow and put plus 5. Come down to the next line, and we're going to put a 9 in there. And that works because you got to watch out for those things, because if that's bigger than 10 or -10, we're going to have to zoom out or something to be able to see it, because our standard window only goes to 10 and -10. So let's take a look at that. Okay, all right. So we see that it has 2 solutions. Now I'm going to hit, again, how am I going to do this? Second trace, which is calc. Number 5 for intersect. And for our first value, as long as I can see it on the screen, I'm just going to hit enter, enter. It says guess. Well, yes, I want you to guess. Okay, and so our first solution there is x equals 1. Again, we're not worried about the y. They're both going to have y equals 9. Okay, so just the x, because our original equation only had x's, right? All right, so let's try this again. Second, calc 5. But before we start hitting, we need to come over here. I'm going to hit the left arrow, and that has to be just one step closer to that intersection than the other one so that the calculator knows which intersection we're concerned about. So hit enter. Second curve, yes. And do I want to guess? Yes. And there it is, -3. So the solutions for this equation are -3 and 1. Okay, one last deal here for you. Let's go the next equation. This one's a little bit different. Sorry, my last one I'm going to do with you again. And so let me write that down. 3 over 2, x minus 2 plus 3 equals 2. All right, so I have to go back and forth. I'm going to try this guy out. Back to my calculator. Gonna clear all this other stuff out. I'm gonna quit my graphing screen. Clear, and then quit, and come back to my home screen and clear my keys so that it's less traffic down there. So here we go. So y equals, I'm going to hit alpha y equals. That gives me my number 1, gives my fractions going. And whoops, first thing I've done is messed up. I need to put the absolute value bars first. So let me do that. Alpha window, which is F2, let's get that, hit number 1. And now I'm going to hit alpha y equal for F1 to get my fraction set up. And it says 3 on top, 2 on bottom. So I'm going to do 3, down arrow, 2. And then I'm going to hit the right arrow to get out of that fraction, or else everything's going to be in the bottom. Open parentheses, x plus 2, minus 2, minus 2. And then close my parentheses, and hit the right arrow to get outside the absolute value bars, and plus 3. Come on down the next line. Okay, it skipped one. We'll just live with that. And so now I can hit zoom 6 for standard. Let's see what happens. Well, goodness, what are we going to do about this? We're going to say there are no real solutions, is what we're going to say. No real solutions, so they don't cross. So that's kind of pretty cool stuff, I think, So So solving absolute value equations. Yeah, I showed you how to do that by getting it down to the absolute value bars only, and then you can write it twice, once just like you see it, and the second time with a negative on the other side. Solve them both, you get it. So that's how you do it algebraically. But the bigger purpose for this section for us was really to practice the skills on the calculator to solve almost any equation as long as it has a real solution. And even those, we can usually figure out that it doesn't have a real solution, and that tells us we need to go a different route to find to see what's going on from there. So hope that was helpful. It's one of the big stuff, isn't it? Oh, I forgot to tell you. Yeah, it's on our big stuff list. I forgot about that. Did I not get it in here? Yep, didn't do it. So let's do real quickly here, just to remind you, because it is on our big stuff list. It is, nope, number 8. To solve an equation by graphing, put the left side on y1, right side on y2, second calc, intersect. So we've hit 7 of our 8 big stuff items already, and we're just getting started, right? We won't be long before we hit number 6. And if you get these things straight, it'll get you on a real good course as you go through Algebra 2. Have a good evening, and hope that helps.